Hello friends, welcome back to the data structure tutorial, and today we will be writing a code for deletion of a node from the list for three different conditions, that is deletion from the beginning, deletion from the end and deletion from the middle. And in the previous video we have already completed the algorithms and the theoretical part of deletion from the singly linked list. So we have a code which is already completed for the insertion of node at the different locations in the singly linked list. If you have not checked it, please go back and watch those videos. So here we'll be creating another function. So above the display function, I'll be writing one delete function. So I'll be creating void delete. And to this delete function, we'll be getting one data. So integer data. And on this data we need to perform delete operation. So the very first task is we need to search whether the data is present or not. So you will be writing if condition to check the list is available or not. So the first condition is when start is equals to null, means you do not have any list. So you will be writing one message that list is empty and you will go back. Else if it is not the case, then you will be writing your logic. So here you need to search the element. So you will be searching p is equals to start. So we have taken some temporary object p which will be copying the address of starting variable. Then you will be applying your while loop to search the element, and the condition is p of info is not is equals to your data. Till then you have to traverse the list, and suppose in between you will find p becomes null, then it means that that element is not present. So you will print one message that element not found, and you will return. Else you will be copying the previous address into the queue and p will be moving forward. So how to move forward? P equals to p of next. So this entire logic is to search the node which we have discussed in the algorithm. And now we have to check, because p will be pointing a node which is to be delete, whether it is at the end, whether it is at the middle, or whether it is at the beginning. So p will containing that address which is to be delete. And now after this we will check that condition where will it appear, because we will not repeat this task every time. So simply you will check that, you will be checking where is the p. So again one condition, if p is equals to start. So what do you understand from this condition? It is a starting node. And what is the logic of deleting the first node? So p's next becomes your new starting point, and p of next should be null. So it will detach the first node. This is the condition for deletion of a first node. Okay, how will you know that that node will be a last node? So p will be pointing any node if the p's next field is equals to null. It means that that is the last node. And how to delete the last node? We have already copied the previous node of the p as a q. So p is the last node, then q of next should be null. So automatically you will be detaching the last node from the list. Okay. And if there is a middle condition, so if it is not, then obviously it will be the else condition. So everywhere you will be writing else if, and here you will be writing else, and you will be writing your logic of deletion from the middle. So p is a deletion node which is to be in the middle. So the element which is after p has to be copied. So r is equals to p of next, which we have written in the algorithm. So from the diagram you can understand that here you can see that this is your p which is to be deleted from the middle, and this is the last node, and p of next, that is 100, you copied into the r. That is what we have done here. So p of next is copied into r, so you have to declare the variable r So at the beginning of your code here, I'll be writing R is equals to null. So it is just a declaration. And then you will be writing your logic here. So you copied the next element, then in the previous element, so q is equals to, sorry, q of next is equals to R. So q of next is R. So this is your q, and in the next field of q you are copying R. Then p of next must be null. So you will be writing p of next is equals to null. So we have just written the logic. This is the common part for all the three algorithms: deletion from the middle, end and beginning. And this is the base logic where you will be deciding which node is to delete. If p is starting, then you will be writing this. If p's next is null, means it is the last node, and if p is not the beginner or the end, then obviously it will be the middle part. So this is to be deleted. And now it's time to implement this, right? So here what will happen, we have already inserted few elements, so we'll run this much and then we'll call delete function and we'll check how will it look. So I'll just compile it manually. So I'll be writing java c demo sll dot java, and then I'll be writing java demo sll, and this is the my list: 34, 72, 82, 55, 17 and 99. So this is the list which we have displayed till the line number 133. Now what if I call op dot delete? I have called op dot delete. So delete function which we have just written, this one, and we need to send one data which is to be deleted. So let us say that we send one data which is not there in the list. Suppose I have sent one data 500 or 500 which is not there in the list. So it should give me a message that your data is not present. So we'll just compile it. Sorry, I missed the semicolon. I'll compile it again and I'll check it. Now I'll run it again. So we are getting one error there on the line number 72. So it is telling us that the information field will not become null anytime. So we'll just quickly check it. Okay, here. So we missed that this if statement should be after p equals to p of next. That is what happens when you implement it. So in the theoretical part, I think I have written this everywhere above the p equals to p of next. Please correct that. It should be after p equals to p of next. Now let us try to compile it again and we'll check it what will happen. So you can see that we tried to delete a element 500 which is not there in the list. So it is displaying one message that element is not found because that is not in the list. Okay, fine. So let us delete the element which is there in the list. So we have a printed the list. So I want to delete a element 34 which is at the beginning of the list. Okay, and then I'll try to print it. So I'll call the display. So it should print the entire list first. So okay, to better understanding it, what we'll do, we'll write one line here inside the display to the list is, and then we'll write the colon. So I'll clear it again, I'll compile it and I'll run it. Okay, now you can see that this is our first list. So I'll make it more clear. So I'll write /n here and you can check. So this is your first list before deletion till this line, and then you displayed the list. So this output we got, then we deleted the element 34 which is at the beginning of the list and then displayed it. So we have successfully deleted the element 34 which is at the beginning of the list. Okay, then again try to call delete function and send the data which is deleting, suppose 99, which is at the end of your list, and then check by displaying it. So I'll write op dot display. So it will be displaying the element at the elements excluding the element 34 and 99. 34 is deleted from the beginning, 99 is deleted from the end, and the remaining elements are 72, 82, 55 and 17. Now let us check our condition for the deletion from the middle. So middle elements are 82 and 55. So here you will be writing op dot delete the element which delete, suppose 55 you want to delete, which is in the middle, and then you will be calling display function. Let us compile it again and check it. So here we have implemented all the three cases of deletion. The list is this one, original list, then we deleted 34 which is from the beginning, then we deleted 99 which is from the end, then which is not appearing in the next list, then deleted 55 which is in the middle. So remaining elements are 72, 82 and 17. So we have successfully completed the algorithm of insertion at the three conditions and deletion from the three different conditions. So I hope that all of you have clear idea of singly linked list. Now we'll see you in the next video.